Welcome to the channel Avenue Tricks. Today we are trying to explain how to test statistically between two means. We have taken an example, a case study, which is about annual income of 278 households before and after the intervention. In this regard, we have two statistical tests are available: the parametric test, which is the paired sample t-test. We use the paired sample t-test because the two samples are related, or the individuals have been interviewed in the baseline and after the intervention. So for the paired sample t-test, we need to fulfill the assumptions, because the t-tests usually follow the normal distribution. Therefore, the dependent variable should follow the normal distribution. The benefit of non-parametric test is that these tests do not follow any distribution. The alternate of the paired sample t-test is the Wilcoxon paired sample t-test. Let's see with the software SPSS with a live example of a survey data of 278 households. Okay, here we have taken an example of 278 household data, household income data of the baseline income before. It means in the baseline income after means the income after the interventions. We will try the parametric approach. For this, we need to go to analyze, then click the compare means button, and then go to the paired sample t-test. Here we have pair. We have two variables, so variable 1 and variable 2. The first variable is the income before, and the second variable is income after. In the options we have 95%, and then we have to just click OK. So here is the output. We have annual income before intervention. The mean is 37984, around 37,984 is the average income of the household of 276 individuals, and after the intervention is the 52,794 average income. And statistically, if we check paired sample, this correlation is there is statistically significant correlation. This difference is significant. So the ANOVA is here. If we check the ANOVA, the sign two-tailed, SIG sign two-tailed is basically the p-value. We analyze, we interpret the whole difference using this table only. The others are also used in the analyzing, but we will focus on this. Here we can see that the p-value is 0.000, 0.00, which is statistically significant, because if the p-value is less than 0.05, we usually say that there is significant difference between the mean. So this is the statistically significant. But the problem is that whether we checked the assumption for the t-test or not. What is the fundamental assumption? The fundamental assumption is the normality. So let us check the normality for the variables. How to create a histogram is to go to graph the chart builder and then press OK. So here we have number of charts available. We will just focus on the histogram. Click histogram and drag it to the chart preview, and take one of the variable and like this, press OK. So here is the output we have. So we can see that chart, the histogram is not showing the normality because it is skewed. Most of the means are near 0 to 2000, and very less are between 4000 to 10,000. So this is the case that here the assumption of the t-test is not being fulfilled. So we can say that the above results statistical results are not valid, are not viable, because these do not fulfill the assumptions. So now what we do is basically we will check the alternate available to test if a parametric test assumption is not fulfilled. We have Wilcoxon test available, which is the alternate of the paired sample t-test. For this we go to analyze again, and then go to non-parametric test, and then go to the legacy dialog, and then select the two related samples, the two related sample option. After clicking, we can have a multiple test here: Wilcoxon, sign, MC, namer, marginal, homogeneity. The first two, Wilcoxon and the sign test, are used as a alternate for the paired sample t-test. However, for this case we just apply the Wilcoxon paired sample t-test. So variable first and then variable second, just press OK. Okay, so here again to check the significance, this is the test, is the z value, and this is the p value. This table serves the statistical significance. So the p value is again 0.000. It means that the difference of means, the means before the average income before the intervention and after intervention are statistically significant. So now we have used non-parametric test which do not follow any assumption. So hence we are quite confident to say that our results are viable and statistically significant.